All right, how you guys doing? Today we are doing the quadratic formula. All right, this is something I've seen a couple of you using already on your homeworks, even though we haven't learned it yet. All right, but it's going to be a crazy looking formula. But before we get there, let's try this warm up. This warm up, all three questions. This is a great review of stuff we've already done. So why don't you guys try the first part of this warm-up, all right? So this is what we talked about from Monday's lesson. So go ahead and pause the video and try finding the vertex of f of x there by completing the square. All right, so to get this in vertex form, we have to complete the square. Right, so I'm going to move this 12 over to the other side first. So that's going to be f of x minus 12 equals negative x squared plus 8x. Right, and remember, in order to complete the square, this coefficient has to be 1, a positive 1. Right, so right now the coefficient is, it's negative 1, right? So we have to factor out that negative 1. So f of x minus 12 equals, if I factor out that negative 1, I have left over x squared, right? Negative 1 factored out from the 8x gives me negative 8x. And inside the parentheses part, this is where we are going to complete the square. So to complete the square, we add half of this value squared. So negative 8 divided by 2 is negative 4. And negative 4 squared is positive 16. All right, so we can't just add a 16 here. We have to add the same thing to the other side. But remember, whenever you factor out, you have to be careful. We didn't really add a 16. We added negative 1 times 16. So on the left side, we're going to add a negative 16. Then cleaning this up, negative 12 minus 16 is minus 28 equals negative 1 times, right, we completed a square, so this is a perfect square trinomial. That is going to factor to x minus 4 times x minus 4, or x minus 4 squared. Right, the trick is, again, half that middle value. Or you can think negative 4 times negative 4 is positive 16, right, and negative 4 plus negative 4 is negative 8. So that is how that factors, and let's move that 28 back over. F of x equals negative x minus 4 squared, all in parentheses, plus 28. Right, if you want to put in the 1, go ahead and put in the 1. You don't need it though. So there is our equation in vertex form, and we got there using completing the square. So using this, we can get our vertex. That is going to be positive 4, comma 28. All right, I'm also going to ask you right now, is that vertex a maximum or a minimum point? All right, so think about what this negative means for a parabola. Is this a smiley face or a frowny face parabola? Right, that negative will make it upside down, so we know that vertex there, right, it has to be a maximum. So not part of the question, but good to know that that will be a maximum value. All right, so that is one way to get the vertex by completing the square. But there is another way, and we can use the formula for the axis of symmetry. I just wanted to go over this again. Right, do you guys remember the formula for the axis of symmetry? It is x equals negative b divided by 2a. Right, we did it the other way also by averaging the two zeros, the two x-intercepts. Right, but there was also this formula, x equals negative b over 2a. So if we use this formula to get the axis of symmetry, well, remember this is ax squared plus bx plus c. Right, so our a value, that's the number in front of the x squared, that is negative 1 here. So we can say a equals negative 1, our b value is equal to 8, and our c value is equal to 12. Right, we didn't We don't need the c value, but just so you know. So our axis of symmetry is going to be x equals negative b. b is 8, so negative 8 divided by 2 times negative 1. a is negative 1. So our axis of symmetry is 4. Negative 8 divided by negative 2. That's 4. So 1, 2, 3, 4, right? Our axis of symmetry is here. We know this is a frowny face parabola. So whatever our parabola looks like, right, the vertex is on the axis of symmetry. So to find the coordinate, we're going to plug in a 4, and we're going to get the y value. So let's plug in a 4 here. So f of 4 is going to equal negative 4, plugging in for the x, squared. Right, notice I didn't put the negative inside the parentheses. That's because that only this x part's being squared, right? That negative is not part of being squared. So it's negative in parentheses 4 squared, we're just plugging in 4 for x, plus 8 times 4 plus 12. And that's going to equal negative 16 plus 32 plus 12, which is negative 16 plus 44, which is 28. So when x is 4, we're equal to 28. The function's equal to 28. In other words, f of 4 equals 28. Or we have the point 4, comma 28 again. Right? So same vertex, a completely different method. Right? In this method, we found the axis of symmetry using that formula. And we know our vertex is on the axis of symmetry at that x value. So we just plug in that x value, which we found was 4. So 4, comma 28. And that's the way we did it before we learned completing the square. So that was a good review. And lastly, let's find the exact zeros by completing the square. Then let's round our answers to the nearest tenth. All right, again, another word for zeros are x-intercepts or roots. And whenever we're looking for x-intercepts or roots, we're going to make our y value equal to 0. Right? In other words, we make the function f of x equals 0. So, to get the zeros, I make f of x, right, equal to 0. So 0 equals negative x squared plus 8x plus 12. All right, we are completing the square again. So I want to isolate the x terms, so I'm going to move the 12 over. Right, negative 12 minus 12 on both sides. And I get negative 12 equals negative x squared plus 8x. Alright, so when we get in vertex, when we factor out the negative 1, you can still actually do that here if you want. But when we're solving the equation, it's typically easier to just divide everything by negative 1, divide everything by that a value. Alright, and that's going to give us 12 equals x squared minus 8x. And now I'm going to complete the square. So again, half of negative 8 is negative 4. Negative 4 squared is 16. And so I add 16 to both sides. I get 28 is equal to, when we factor this, like before, we're going to get x minus 4 squared. Right, and because we're solving, we're going to square root both sides this time. Right, and when you square root, do not forget the plus or minus. So I get x minus 4 equals plus or minus the square root of 28. And just because I know you guys are more used to it, I'm going to put my equal sign on the right side like this and put the plus or minus 28 to the other side, just out of preference. And can we simplify this radical? Right, it did say simplest radical form, so let's take a look. Square root of 28. Perfect squares. 4 goes into it, right? 9 doesn't divide into 28, and 16 doesn't, and 25 doesn't. So I could break it down to square root of 4 times square root of 7. That's 2 square root of 7. And so x equals, I'm going to add 4 to both sides, 4 plus or minus 2 square root of 7. And that is my final answer when they asked for exact zeros. So exact zeros means no rounding. This is our exact irrational solution, right? You don't want to write it as a decimal because it's an irrational number. Irrational number has infinite number of decimal places with no repetition, right? So there's no way to write it unless you leave it in the square root form. Right, so this is really two solutions. This is really x equals 4 plus 2 square root of 7, and also x equals 4 minus 2 square root of 7. Right, these are the exact answers which they asked for, right? And then it said, also round your answers to the nearest tenth after. So what is 4 plus 2 radical 7 equal to? Well, we can type this into our calculator, and well, let me get this on right now. 4 plus 2, square root button is next to the number 4, so 4 plus 2 square root of 7 is 9.2915, which is about 9.3. Right, and this value here is 4 minus 2 square root of 7, and that is about negative 1.3. Right, so these weird, scary looking numbers, they're just about 9.3 and 1.3, or negative 1.3. So that's where my two zeros are. So with all this information, we can make a very nice sketch. So I'm going to draw my x and y axes. I know I have a 0 at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 1 at 9.3 and 1 at negative 1.3, so I go negative 1, negative 2, negative 3. So I have a 0 here at negative 1.3-ish, right, and another one at positive 9.3. And my vertex was at 4, comma 28. So 1, 2, 3, 4. And let's make 28 somewhere over here. Alright, just a sketch, so it doesn't have to be scaled accurately. You don't have to draw 28 tick marks, right? You also don't have to scale the x and y axis by the same amount. But connecting those dots, I would definitely label the vertex 4, comma 28. We can also find the y-intercept if we like. Right, we get that just by plugging in a 0 for x. Right, because this point, the y-intercept, that's 0 comma something. So if you plug in a 0, right, all of that's 0. 0 squared is 0. 8 times 0 is 0. It's just 12. It's going to be that c value. So that's 0 comma 12 if you want. And we got our two zeros at, what is that? 0 comma negative 1.3, right, and that 0 at 0 comma 9.3. And again, these are rounded values. The exact values are these decimals, or these radical forms over here.